Man's fascination with the planets has been with us since the first humans looked into the sky at night and attempted to understand the points of light which moved about seemingly on their own. Until the development of sophisticated telescopes, the only planets which man knew of were the inner planets, Mercury, Venus, Mars, and two of the outer planets, Jupiter and Saturn. Of these known planets, Mars has probably held the most fascination for us. Early in our study of this planet, it was believed that the god of war lived there, hence the name Mars. Later, when early astronomers discovered what they thought were canals on Mars, they theorized that an alien civilization lived upon the planet. Aliens who carved out vast waterways to bring water from the poles to quench a desperate need for the life-giving liquid. In many ways, the beliefs held by these astronomers about the mysterious red planet were caused by an intense desire to find some other place in the universe that was like our home, the Earth.
And what of the Earth? Earth, the third planet in our solar system, is located an average of 93 million miles from the Sun on a nearly circular orbit. It is currently tilted on its axis 23.5 degrees. I say currently because we know that the Earth's tilt can vary by as much as 2.5 degrees over a period of 40,000 years. This fluctuation in the tilt of the Earth could be what accounts for the past ice ages which have occurred on our planet. Periods of history where huge glaciers have covered much of the land mass present in the world. The last such ice age ended only about 10,000 years ago.
The Earth itself, as well as most of the solar system, is about 4,600,000,000 years old. We know this from scientific dating of rocks and meteorites which have fallen to Earth. As old as that may seem to us, it is relatively young when you consider that the age of the universe could well be hundreds of billions of years.
But how does the Earth compare to the other planets? As you can imagine, our blue planet is absolutely unique in many respects.
Were you an alien traveling through the solar system, let's say, on a tour of the 9 planets, the one remarkable thing you would notice about the third planet from the Sun is its color, brilliant blue. No other planet reflects this particular color, which is due to the existence of water vapor in the atmosphere. Beautiful swirling white clouds give contrast to the blue of the oceans as they pass over the greens and browns of the continents.
Our atmosphere is made up mostly of nitrogen, carbon dioxide, and oxygen, with trace amounts of helium, argon, and believe it or not, krypton. The other planets in our solar system either have little or no atmosphere, or atmospheres made up of hydrogen and methane. The Earth's atmosphere is extremely tenuous. It extends to only 248 miles above the surface of the planet. We humans, and indeed all life forms that roam the surface, cannot live above 25,000 feet from the ground. Above that height, the atmosphere becomes so thin, our bodies cannot absorb enough oxygen to sustain life.
The atmosphere of the Earth is a place of constant change. The heating of the surface during the day and the subsequent cooling at night, along with the rotation of the planet, all work in concert to create a flowing dynamic pattern, what we commonly refer to as weather. Another thing you would notice is that unlike Mercury or Venus, the Earth possesses a large satellite, the Moon. It is the first planet in the chain of planets that make up the solar system to have one. The Moon, as it turns out, is absolutely devoid of any of the organic materials necessary for life. It is too small to have held an atmosphere for very long after its formation, and its pockmarked appearance tells the tale of billions of years of cosmic pounding by meteorites, some large enough to have melted the surface and thrown chunks of rock hundreds of miles. Unlike any of the planets in our solar system, men have been to the Moon. So far, only 12 human beings have walked its surface. bringing back invaluable data in the form of lunar rocks. These rocks reveal that the Moon, though created about the same time as Earth, was not originally part of the Earth, as many people believe. It is made up primarily of feldspar, potassium, iron, and magnesium.
There are currently no missions planned to return to the Moon. The last humans to walk its surface left in December of 1972. Should we decide to begin in earnest our human exploration of the other planets, there would be no better starting point than a base built on the Moon. We will return to our old friends someday, and it will help us unlock the mysteries of the universe.
As you probed past the Moon and past the atmosphere, you would notice that Earth is the only planet in the solar system whose surface is almost completely covered by liquid water. In fact, 70% of the Earth's surface is covered by water.
This water was not always here either. When the Earth was first forming, incredible volcanic activity forced hydrogen and oxygen molecules together and released them as steam. As the steam cooled, it began to form droplets which fell to Earth as rain. Now, as this rain fell, it began forming first puddles, then lakes, then rivers, streams, and finally, vast oceans.
The oceans of the Earth are in constant flux, and these oceans are where life began. The complex process which keeps the ocean water on the Earth, in turn, allows us and every other organism on the planet to remain alive. For without the oceans, life as we know it could not exist. Strong currents caused by the rotation of the Earth and gravitational pull of the Moon distribute the ocean's water all around the globe. The heat from the sun causes the water to evaporate and drift into the air. As this water vapor reaches ever higher altitudes, it begins to cool and condense. As it condenses, it forms rain droplets which fall back to Earth to eventually flow back into the sea, and thus to begin the process all over again.
Indeed, the water that all living organisms ingest has, over the billions of years of its existence, made this journey countless times. Think about that. The water that you drink today not only is literally billions of years old, but once may have been the very same water that was drunk by a dinosaur, evaporated from his body through his skin or breath, condensed into clouds high above the Earth, and then fallen as rain to the surface to begin again that endless cycle which not only gave life to the dinosaurs, but to us humans as well. Now, while there may be vast amounts of water on the surface of our planet, hardly any of it is fit to drink, at least for us humans. For example, if you were to take all of the lakes, all of the rivers, all of the streams, indeed all of the creeks and man-made reservoirs, all of them in the world, and add them together, you would have only 1% of the total water on the planet. Now, when viewed in that light, you can see how serious we must be in the care and usage of such a rare and valuable commodity.
The Earth's crust is not as solid as we imagine. In fact, it is broken into several pieces called plates, which float on a sea of superheated liquid rock known as magma. These plates are in constant motion, moving across the Earth's surface, carrying islands and whole continents with them. In fact, at the time of the early dinosaurs, about 225 million years ago, all of the continents as we know them were joined together as one huge mass continent known as Pangaea. We know this because we have found that several identical specimens of dinosaurs can be located on different continents scattered all over the planet's surface. Where these continents are separating one from another, we find huge amounts of liquid rock pouring forth from the ground, what we call volcanoes.
Now, where these continental plates are coming together, we find the ground pushed up to great heights, what we call mountains. It is important to realize that every mountain range, every hill for that matter, in the entire world has been formed by the movement of the Earth. Now, this movement of the Earth's surface goes on continuously, though the only time that we humans are made fully aware of it is during its most violent moments, and those times are called earthquakes.
In one particular case, the state of California is divided into two huge plates, the Pacific Plate on the west and the North American Plate on the east. The The dividing line between these two is known as the San Andreas Fault. Unlike many fault lines that form the boundaries between other plates on the Earth, the San Andreas is known as a strike-slip fault. This means that the two plates are sliding against one another, the Pacific plate moving north and the North American plate moving south. Since the two are definitely not separating east and west, it is clear that the coast of California will never fall into the ocean, as has been predicted in the past. What is likely to happen, however, is that within 1 million years or so, Los Angeles as we know it will become a suburb of San Francisco. So great will its northward movement have been.
Mountains, volcanoes, and earthquakes aside, what makes our planet so remarkable within our solar system is that one property which allows us to discuss this subject at all: life. Nowhere else in the solar system have we found anything like what we have here on Earth. This planet is literally teeming with life forms, organisms of all sizes, from elephants and whales to single-cell amoeba. Life is found everywhere in the world. We found microbes in the ice floes of Antarctica, as well as sulfur-eating bacteria around the deepest underwater volcano vents. You simply cannot go anywhere on Earth without being surrounded by millions of different forms of life.
As far as we can tell, life began on the planet Earth some 3,100,000,000 years ago in the form of bacteria-like creatures. These bacteria were present all over the globe and lived in shallow pools of water. We have found their remains in rock dated back to that time. At about 2.5 billion years ago, the first complex organisms began to be found. These were mostly worms and jellyfish, once again, creatures which lived in the sea. It took several millions of years before the first creatures evolved with which we could identify today. Originally, these were the shellfish, clams, and mussels, then insects such as beetles and some spiders, then eventually fish, and most importantly, amphibians.
It is these amphibious organisms which quite literally crawled out of the prehistoric muck to live outside the ocean that would later develop into reptiles, cold-blooded lizard-like beasts, and mammals, warm-blooded animals like ourselves. For a while, a sort of half-breed, the mammal-like reptiles seemed to be the creatures of choice, the ones best suited for life on the lands of Earth. But then, 225 million years ago, a change occurred. And no one is quite sure what exactly this change was, but it marked the beginning of the reign of huge reptilian monsters which dominated the land and the water. It was the time of the dinosaurs.
Dinosaurs lived on the Earth for a period of about 161 million years. 64 million years ago, nearly all of them became extinct. No one knows exactly why, but it appears as though the Earth changed in a significant enough fashion that they were not physically able to cope with these changes, and therefore they all died.
After the extinction of the dinosaurs, mammals became predominant, maybe because they were no longer being eaten by hungry dinosaurs. Anyway, these mammals continued to develop, and about 3 million years ago, barely a blink in the life of the Earth, our earliest human ancestors appeared. Now, modern man has only been on this planet for about 50,000 years, barely a single tick in the clock of the Earth. Yet we have progressed beyond any other organism which has preceded us. We are now in a position where we can change not only the surface features of the planet, but its atmospheric and chemical composition as well. No other creature has literally molded the planet to suit its needs as we humans have done. And no other creature has caused as much damage to the ecosystem of the Earth as we have.
We have an awesome responsibility to this planet. Nature has provided us with all that we need to live and prosper. Through our manipulation of the elements, we have altered the environment. Several species of animals have either become extinct or are nearing extinction due to the works of man. We have poured huge amounts of harmful chemicals into the air and water. We have cut down vast amounts of forest land to make way for human habitation.
Though this may sound like a dismal indictment of our civilization, all is not necessarily lost. Though we have plundered our planet's many resources, We've also taken the time to study our world and to develop a better understanding of how it works. Already, movements are afoot to correct the imbalance which we have caused. We've launched space probes to study our planet and to observe the subtle changes which could spell disaster for our future. We have developed the means to either enhance the Earth's natural gifts to our advantage or to destroy that upon which we depend to survive. As we have seen, our world has the incredible capacity to be a delirious heaven or an unmitigating hell. It is up to us to decide exactly where we want to live.
Which leads us to one of the few places in this hostile solar system where we may one day find an alternate home, Mars. Mars, the fourth planet from the Sun, after the third, which is Earth, is not nearly as big as most people imagine. In diameter, it is half the size of the Earth, about 4,213 miles. Although it is half the size of Earth, its mass, that is its weight, is only 1/10 of ours. Mars is clearly made of much lighter elements than our home planet.
Much has been made about Mars throughout man's history. It was named after the Roman god of war, appropriately, for it is the only object in the nighttime sky that reveals clearly a color, red. The ancients believed that the blood of men slain on the battlefield colored the planet. We now know that it derives its color from an abundance of hydrated iron oxide on the surface. Not very romantic, but scientifically more precise. Mars is dissimilar to Earth in many ways. For instance, its year, the time in which it takes to circle the sun, is 687 Earth days, about twice as long as ours. It does, however, have a day that is almost exactly the same as Earth's, 24.4 hours. And very importantly, it is tilted on its axis, almost exactly the same as Earth, which gives it a change of seasons, just as we have here, except for the fact that Mars seasons are longer.
The surface pressure of Mars is about 1/100th that of Earth, and the atmosphere of Mars is not very hospitable to human life. It is mostly carbon dioxide, nitrogen, argon, and a small amount of oxygen. Though it is insufficient to sustain human life, it is rather similar to the chemical makeup of our own atmosphere. Theoretically, you could breathe the air of Mars. But there is so little oxygen in it that you would surely die within seconds of doing so.
The atmospheric pressure on Mars is equivalent to the atmospheric pressure you would feel at 100,000 feet above the surface of the Earth. So it's not likely that you'd be able to take a breath of it and survive.
Temperatures are not quite what you would call balmy on Mars either. During the peak of the summer on the planet, the temperature on the equator may get as high as 40 degrees Fahrenheit, but at night that would dip down to minus 140 degrees. Close to the coldest temperature recorded on the face of the planet Earth. Again, not a very bright picture for human existence on the planet.
There is one thing we know that Mars has, however, that raises the most excitement when discussed. Mars has a substance that occurs naturally in great abundance and is invaluable to mankind. A substance which is not rare in the solar system, but is more precious than gold or platinum. Mars has water.
Early astronomers who painstakingly observed the planet for hours on end drew pictures of the planet with representations of huge canal systems running the entire length of the planet's surface. This is quite extraordinary, as we know that it was quite impossible for these early observers to see any kind of significant detail on the surface due to the limited optics that they had in their telescopes. Yet several different and notable astronomers drew these canals time after time. How they did it, no one knows. What we do know is this: there is massive erosion on the surface of Mars. Huge valleys have been cut into the planet, some with cliffs that stand 15,000 feet over their bases. Channels and estuaries cut into solid rock, all of which could only be the remnants of once great rivers and oceans of running water.
So where did all the water go? Well, out into space, most likely. The atmosphere of Mars is extremely thin. So thin, in fact, that liquid water on the surface would boil away without heat, and ice would slowly evaporate and disappear. At one point in the history of Mars, there must have been enough atmospheric pressure to hold all the water in. For it's very obvious that there was a considerable amount of it on the surface of the planet. There is also evidence that seems to indicate that water in liquid or ice form still exists underneath the surface soil.
And the argument in favor of that is right here. You see, all planets show signs of being impacted by meteors of various sizes. In the early formation of these planets, these impacts occurred with some regularity, hence all the craters on the Moon. Earth was subject to the same bombardment, but since our atmosphere is so active, the wind, rain, and rivers washed away most of the remains. However, on dry planets with little or no atmospheres, such as Mars, these factors do not account for much erosion. Therefore, the craters are still there. But what does that have to do with water on Mars? Well, let's take a look at a typical crater and see how it is formed. A crater is formed when a large object, usually a meteor or asteroid, collides with a planet, or in the case of the Moon, a satellite. As the meteor strikes the surface, it generally heats up the impact area sufficiently enough to melt the meteor and the surrounding rock. This then flows forcefully outward in all directions, leaving a crater in the center and a telltale spew of ejecta around the crater. In almost every case, the ejecta appears to be made up of melted surface rock and melted meteor, except on Mars. On Mars, much of the ejecta looks exactly like flowing mud. This then would tell us that Mars still has water, either in the form of flowing underground springs or as subsurface ice. In either case, we have a planet to which we can go and find that one resource that will allow us to live there permanently. With water, we can make oxygen to breathe, and we can grow plants and animals to eat. We can go to Mars and we can live.
The big question on Mars is, where did the water go? Certainly some of it is contained in the polar caps, but not nearly enough to explain what we can see there. The subsurface area, that is the first few kilometers of material between the surface and the center of the planet, are a likely possibility. We have seen several things on Mars that indicate that there is a layer of something that you could loosely call permafrost, and that if you dug down not too far into the surface, you might find the water that we know was there and the water that would be necessary for humans to be there eventually.
Mars is a vast desert wilderness of red soil and blue skies. It is home to some of the largest cliffs and deepest valleys in the solar system. It has the largest known mountain of all the planets. Nearly 3 times higher than Mount Everest, it is called Olympus Mons, a dormant volcano, silent witness to an age of great oceans of running water, along with tremendous volcanic activity. Mars, for all its strange beauty, is a veritable wasteland. As far as we know, nothing could live on its surface. There is no ozone layer to speak of, so deadly ultraviolet radiation from the sun rains down mercilessly on the soil. Surface temperatures anywhere on the planet seldom rise above freezing, and then only for an hour or two a day at the equator. At first blush, Mars would appear to be an interesting but dead world. But then again, maybe not. It is mere speculation, but if it can be found that there does exist subsurface liquid water far enough below the soil to eliminate any of the ultraviolet radiation from the sun, then perhaps there can be found life. The Martians could very well turn out to be microbes, and where microbes can live, mankind can live.
We are fairly convinced that in the surface layer, in the boundary layer between the surface and the atmosphere, that life is not likely unless it's so different from anything we know as life that it would be hard to define. So many scientists are now saying that we need to investigate this area just under the surface, where there's protection from the ultraviolet light and where there's a possibility of water. We know that, at least in the places that we've looked on Mars, this surface layer consists of oxides of various things, and so we know that there's a possibility for derivable oxygen. What we don't know is what kinds of life could survive in that thin layer.
Currently, there is much talk of a manned mission to Mars, perhaps with the Soviet Union and the United States acting in concert. One thing remains clear. If we put forth the effort, man can travel to Mars, can live there, even develop a civilization there. Water can do many things. It is the universal solvent of all life as we know it on Earth. With it, as we said, you can make oxygen to breathe, you can raise food,
You can use it to feed plants, which will give off gases that will change the atmosphere of the planet to make it more hospitable to life. Our future journeys to the stars must begin with a base camp firmly entrenched on the planet Mars. Then, and only then, can we say that we have seen the Martians and they are us.